Right, so if we load up Paraview, here's one I made earlier. So once you run the basic pipeline, you will end up writing the .dream3D file. So if we find our way to that, so you will see Paraview can only see your .xdmf, so that's your header file, so it can't see the Dream3D file. So you'll point it to the .xdmf, which you create. You've got 3 choices of XDMF reader. I don't know what this means. I just go with the top one, and it seems to work. So then you've loaded in your data. We have it here in the pipeline browser here. So this is called a pipeline. This is different to a Dream3D pipeline, so just ignore that, because you can actually run through, similar to a Viso, you can have a visualization pipeline in Paraview, but that's a different type of pipeline. So once we've loaded our data, the first thing we will do, because we want to have a look at it, we'll firstly click apply, which loads it into memory. So we'll click apply there. Then for me on this laptop, it'll take a while. Oh, it's pretty quick. It'll be quicker on your computers. And then we'll see we get our reference frame because it knows the size of our data. So we'll get this box here, which is basically surrounding our data, but we can't see anything inside it. So if we want to see something, the way I usually do it first is I will click this button here, which is our threshold, which is this letter T inside the 3D dataset threshold. So if we click that threshold, it'll bring up a new threshold in the pipeline here. Can everyone see the screen, by the way? Am I in the way? Good, right, and then we will go threshold, and then we can see we can threshold the data in this drop-down list. We can threshold the data using whatever scalar quantity from our cell data we want. So I'm going to use mask. So if we click mask, remember we've ran our threshold objects filter, which means that each voxel has either a 1 or a 0 for if it's in or out of the mask. So if we threshold our data, click the refresh here, to 1 and 1, that will basically, and then we click apply, that will visualize every voxel in the data set which has a mask value equal to 1, which should be all of our actual data. So if we click apply, again, this will take a while on my laptop, but will be quicker for you, hopefully, on these machines. Uh-oh. It's coming. Right, brilliant. Right, so this is a cropped version of the zirconium dataset I showed you earlier. Again, we just cropped this yesterday just so it's easier to work with today. But this is part of a larger dataset. You can see where it's been cropped off there. So that's basically our mask. So this shows us all of our index points. And then we can basically do a lot of playing around with it if we want. We can color it for anything we want. So this coloring at the moment is our original band contrast, BC. This is the band contrast of our original EBSD map in 3D. You can see the coloring here is a bit weird. So if we want to change the coloring of anything, we can go to View, Color Map Editor, and that'll bring up this on the right. And you can see if you go down here to this, is it this one? We can change the color scheme to anything you want. So if we went X-ray, it's kind of inverted, but that'll be similar, inverted to your classic band contrast. So we can color this. This is actually quite nice because you can see all the hydride. You can see the SPPs in the grains as well. So basically, you can change the color scheme however you want from each of these things. Just select whatever you like for that. That's pretty cool. And then, so we can now color the 3D volume for any of our attribute arrays we have on our cell data, which is pretty cool. So now we have a unique feature ID because we've ran the segmentation filter. We can color these for feature ID, and this will just basically randomly color them according to whatever the number of the feature ID is. IPF color is what people want to see quite a lot. So if we go IPF color, we can see that looks a bit weird. That's because IPF color is a non-scalar value. So if we go here to scalar coloring and we untick map scalars, it will then go into our nice recognizable IPF coloring. So that's really important when you're doing your RGB colors, is to make sure you untick map scalars, else it'll look a bit weird. If we want,
is there a way to see the legend for the IPF?
No, because Paraview doesn't know this as orientation data.
Right.
So we'd have to get the legend. You'd have to go to Dream 3D. Don't know if that.
I see what you mean. Yeah.
So the IPF color is.
So yeah, it's already spat out as RGB.
It's already spat out as RGB,
yeah,
exactly.
Yeah.
So Paraview is not stupid, but it doesn't know this as orientation data. So Paraview was actually written for computational fluid dynamics. For modelling, so it's not really made for 3D data, but for 3D crystallographic data, but it works. What else do I want to show you? Phases is boring. MAD. Yeah, there's not that much to see on this basic data set. If we want to pick out a grain from the 3D volume, so we want to have a look at this blue guy here. There's this feature here, you can select points. Is it this one? Select points on. Click that. Drag a box here and it'll select those cells there. And then we can use this find data filter here. Is it there? This one. Find data, and that will point all those cells you've selected. It will tell you all the detail you have for them, including, crucially, the feature ID. Oh no, that's points. Sorry, not points, you want cells. Select cells, that's the one. Give it a sec. And this will tell you all the data it has for those cells you've selected, including the feature ID. Oh, sorry. Select cells with polygon, that's the one. This is selecting all the ones in that volume. Let's go there. And this will tell you the feature ID, and then we know that that grain is numbered 164, we can see there. So then we can then do another threshold, go back up to our data, threshold, and now we can threshold, what did I say, 164. We can threshold to feature ID, 164, 164, apply, and that'll pull out this individual grain, hopefully. So now if we, to get rid of the rest of the volume, we can now see we've got our nice little grain there, and then we can colour that however we want. You can see it intersects this outer surface. And then if you want to centre on that, you can click this one, that'll centre it, and then you can view it from any, let's get it in IPF colour. Okay, so that's kind of basic visualization. There's obviously a lot more you can do. One thing you will notice is this voxelized surface, obviously from the EBSD data is voxelated. So after lunch we'll talk about how you can mesh this surface to get a smoother grain surface and start to look at grain boundary properties. But yeah, that's basic visualization. Hopefully that'll give you enough to play with. So I reckon now we will run through the pipeline on each of your machines. You've got the